Hi. Today we're going to be learning about perfect squares and how to represent them on a virtual geoboard. First, we need to know what a perfect square is. Well, a number is called a perfect square if it represents the area of a square whose side lengths are a whole number. Alright, so we're going to represent that on our geoboard. But first we need to get there. So in order to go to our geoboard, we need to go to our worksheet and go to this link. This will bring us to where we need to go. Alright, so this is our geoboard. We're going to want to press this rectangular board because we're going to want a lot of space. So let me show you an example of how to show a perfect square with these. You can choose any rubber band by picking it up and dragging it to the geoboard. It doesn't matter which color you use. I'm just going to use white just because it's the easiest one for me to grab right now. So I'm going to make a square with side lengths 3. Alright, so I'm going to drag these along. I'm going to make a square. Alright, and whoops. Let me just make this a little easier for myself. There we go. Okay, now we are going to say that this length is 3 and this length is 3. So we're going to want to find the area, which is also our perfect square. So how we find the area of a square is the area is equal to the side lengths squared. So in this case, our side lengths are equal to the length 3. So for our area, it's going to be represented as 3 squared, which is equal to 9 as our final answer. So we showed not only that that is our area, but it also is a perfect square because of the definition that we gave. Alright, so let's go back and look at our worksheet real quick. Okay, for question number 1, use your geoboard and rubber bands to model each square and complete the table below. So in order to get you used to what you have to do in this worksheet, I'm going to do the first one with you. Okay, so here we go. I'm going to clear this out with this button here. I'm going to get the pen out. So I'm going to make a square with side lengths of 5. Alright, like this. Alright, just gonna measure it out, make sure that your lengths are correct, because that is important. Alright, and now we are going to write down these. Side lengths are 5, side lengths are 5. Each of them are 5. So, one of the questions it had is we need to find the area. So if you remember, the formula for our area is our side length squared. So in this case, the area is going to equal 5 squared, which is equal to 25 units squared. And remember, we need to say units squared because when we multiply 2 unit lengths together like that, the units become squared as well. Alright, now we also have to find the perimeter. If you remember, the perimeter is equal to, in this case, it's going to be equal to 4s because we're going to be adding together each of the lengths of the sides. In this case, because they're all equal, we can just say that it is 4s. So our length of s is 5, so it's going to be 4 times 5, which is equal to 20 units. And it isn't units squared because we didn't multiply two unit lengths together. We just multiplied it by that because that's how many sides there are in a square. There are 4 sides. So you have to multiply it by 4 to find the perimeter. So we go back to our worksheet, and we're going to record this in our worksheet. Ooh, it's a little number right there. All right, 25 units squared and 20 units. Now I want you to go and work on these and pause the video, and once you have found your answers, unpause the video so you can come check. Alright? Alright, so we are now checking our answers for this particular question. Alright, so we already showed the first one, that the 5 units equals the 25 units squared for the area and the 20 units for the perimeter. For our first 4 questions of 8 units, 7 units, and 2 units, we're able to find it in a very similar way. We square the side lengths of the units, and then we multiply the side lengths by 4 in order to find the perimeter. However, for the next few, they're a little trickier because we're given the perimeter instead of the side lengths. So let's go back to our geoboard real quick and try to figure out how we would do that. Okay, so we were told that we have a square with the perimeter of 12. P equals 12 units. So how would we find this? Well, if you remember, we were able to find the perimeter by taking the formula 4s. So we're going to set that equal to our 12 units, and we're going to divide by 4 on both sides, and we find that our side length is equal to 3. And then with that, we can find the area to be equal to the side lengths of 3 squared, which is equal to 9. And we can represent that on our geoboard very, very simply. Like this. And that's our shape. Very, very simple thing to do. And then we also showed another one in that where we showed x as our units. Well, we're going to do the same exact thing that we did before. If we have our lengths as, let me clear this off really quick. Our lengths as x, then it's a little weird. That's not a number that we're used to. That's not even a number, it's a letter. So how would we do that if it's not a number? Well, we do it the same exact way because this x is a representation of a number. So in order to find the area, we need to have it as s squared. But in this case, all you got to do is the same thing that you were doing. So it's going to be equal to x squared, or that's equal to x squared units squared. All right, and in order to find the perimeter, we have it as equal to 4s, which is equal to 4x units. So it may seem a little tricky, but it's really not when you start to think about it. All right, let's move on. All right. A number is called a perfect square if it represents the area of a square whose side length is a whole number. For example, 25 is a perfect square because 25 square units represents the area of a square whose side lengths are 5 units. Which column above shows perfect squares? Well, if we look at the example that we did earlier on this, we can very clearly see that our area is the perfect square, because the side lengths, when multiplied together, those two side lengths are whole numbers, which create the area, 25 units squared. So our area column is where all of our perfect squares are. And you can look at this to check it. Alright, so we're going to go to our last question. If you know the side length of a square, how can you find the area without a geoboard? Well, that's actually rather simple. So let's say that, for example, we have the area, we have the side length of 3 units. Now, how would we find that? Well, we would do what we've been doing. We would say the area is equal to S squared. So in this case, our area would be equal to 3 squared, which is equal to 9 units squared. So that's, the geoboard is a really good way to represent what you're trying to show, but you can also just use simple algebra in order to solve it out. So that has been our lesson on how to find the perfect square and how it relates to area and can be shown on our geoboard. Thank you so much.